Hey there, welcome to Accuracy and Precision. We're going to start out with some brief notes and then you'll be able to move into the worksheet. So accuracy and precision are both needed for good science to happen. So let's look at what the difference is between them. Accuracy refers to how close the answer is to what you expect. For instance, if you have a hypothesis based on a whole lot of evidence or past experimentation that says you expect a toy car to travel 10 feet in 3 seconds, and then you test that toy car, and in fact it travels 10 feet in 3 seconds, you would say that your results are accurate. Now there could be all kinds of weird things that happen to make your result not precise, but based on your hypothesis and your background information, that's what you would have expected. To make sure that your results are precise, you would want to use that toy car experiment, or do that toy car experiment, at least 3 times. When we do things 3 times, that gives us a chance to see if our data is the same, or at least very similar, all 3 times. If you do it twice and you get similar results, and you have a third result that's crazy, you throw that out and you try again, so that you can say that the way you are doing the experiment yields the same results every single time. Then we would say that that experiment is both accurate and precise. So when we look at accuracy, we can look at either a single measurement, like I was talking about with that car where you ran it once, or we can talk about multiple measurements. Precision always results from multiple measurements. I can't tell you if you're precise if you only use that car toy once. Precision is also, we can measure it as existing in smaller increments. So when you see a number like 16.1, or you see a number like 16.15, because it has more small increments, it's measuring 15/100ths instead of 1/10. This is going to be the more precise number, the 16.15. So another thing we look at with the difference between accuracy and precision is accuracy refers to how right our results are. It's a way you can summarize it and check for yourself. So another example that often gets used is an arrow hitting a target. If the target, the goal is to get to the bullseye, and you only have one arrow, you can figure out if you're accurate. But it could have been a fluke. The next time that you launch an arrow at that target, it might be wildly off. It might not even hit the target. So to make sure that that arrow is both accurate and precise, or the person shooting the arrow is both accurate and precise, you would want to have multiple arrows. So precision is going to then see how repeatable are your results. If you are doing good lab procedures and you're following your lab procedures, your results should be easily repeatable. And that's one of the reasons why we get so picky about how detailed you are on writing lab procedures and how consistent you are at following lab procedures. The final piece in these notes is to record that you want to make sure you have both accuracy and precision, and so we always do multiple trials. The number I mentioned earlier is 3 trials, and a trial would be having that toy car go across the floor, go those 10 feet or 10 meters. Or a trial would be every time an archer launches an arrow. All right, switch over to your worksheet now. Yep, this is the one I'm talking about. Now let's focus on just this top section of your worksheet. This looks a lot like the arrows that I was just talking about. In this section, you're going to record in line A if this example here shows high or low accuracy, and you can just write high or low. Or if on this example here, B, it shows high or low precision. And again, you can just write high or low. Go ahead and finish that and then start the video again and move on to the next section. All right, in this section, you're going to analyze which of these scientists is more accurate and which one is more precise. So in this line down here, you're going to fill in either scientist A or scientist B. So think about the things that determine whether somebody is accurate or whether somebody is precise, and make your choice accordingly. Pause the video and pick it up again for the final section. All right, here you're going to figure out if the students that are doing an experiment are being accurate or precise. So you're going to use the data in this chart right over here to answer these questions to tell us which student is most accurate and precise, which one is neither accurate nor precise, and which one is precise, meaning they get similar results every single time but not very accurate. Once you're done with that, you're done with this assignment. Nice job.